Hey, welcome back to our second video for Notes 22, where we are continuing to look at ordered pairs and the coordinate grid. In this video, we are going to have to find the ordered pairs for ourselves. Now, to do that, they have to tell me some sort of an equation or a relationship between the x and y values. Notice since x and y are both in the equation, it requires an x and a y to describe that relationship. So here is what we call a table of points. What they're doing is they are giving you an x value. In this first row, they're giving you x to be -2. And what we have to do is plug in x to be -2 to find what y equals in that specific situation. So we take our equation, y equals 2 times, remember, use parentheses, 2 times, plug in -2, and subtract 3. Order of operation says I always multiply first. 2 times -2 is -4. And I have a -3 tagging along. When I subtract, -4 minus 3 is -7, which gave me the y value. So now together, -2 and -7 create one ordered pair on the graph. 2 to the left, 7 down gives me my first point. And then we literally just rinse and repeat. The next one says I should plug in x to be -1 in order to find what y equals. So I take the x back to the equation. Y equals 2 times, plug in -1, and a -3. Just like we did a minute ago, 2 times -1, if I multiply first, that gives me -2. -3 tags along, giving me -5 in all. So when x is -1, y is -5. And together that creates an ordered pair. The rest of this problem, literally exact same process. So if you want to pause and move forward on your own for this problem, you're welcome to. Next up, we're going to plug in x to be 0. So y equals 2 times 0 minus 3. To simplify, I multiply first. 2 times 0 is 0. Minus 3 is -3. So when x is 0, I have a y coordinate of -3. 0 side to side, -3 on the y-axis. This point also is called a y-intercept. 2 more. Next up, we're going to plug in x equals 1 and see what y equals. Well, y equals 2 times, plug in the 1, minus 3. 2 times 1 is 2. When I subtract, 2 minus 3 is -1. Together, that forms the ordered pair +1x, -1y. And last but not least, if I plug in x equals 2, y equals 2 times, plug in, and subtract 3. 2 times 2 is 4, minus 3 is 1. 2, 1. Now you might notice that as we're plotting these points, they end up all lining up. And if I drew a straight line through it, this would be the graph or the visual of the equation y equals 2x plus, 2x minus 3. What you might also notice is that I ended up -3 on the y-axis. That's not a coincidence, considering I subtracted 3 in my equation. You might also notice that I'm adding 2, adding 2, adding 2, adding 2 as I go to that y coordinate. That is also not a coincidence because of the 2 that's attached to my x. In our next lesson, we're going to talk more about where those are coming into play in what's called the y-intercept or slope y-intercept form of a linear equation. But for now, we have a couple of more to look at. For number 4, notice sometimes they gave me x's and sometimes they gave me y's. So be careful where you are plugging into. I'm given the equation y equals 1/2 x plus 4. And I'm plugging in to start off with into the x spot. So if x is 2, we're going to plug in x equals -2. When I do that, y equals 1/2 times -2 plus 4. Please be careful. How do I multiply fractions? Well, I take my whole number and put it over 1. So I have 1/2 times -2 over 1 and a plus 4. When you do that, multiply across the top. 1 times -2 is -2. Multiply across the bottom. 2 times 1 is 2. But thankfully, that simplifies out nicely. -2 divided by 2 is -1. Plus 4 is 3. So I got a y-coordinate of 3 to finish off that ordered pair. Next up, we're going to plug in x to be 0. So I have y equals 1/2, plug in 0, and a plus 4. Well, 0 times anything is 0. When I add 4 to that, I get 4. This is our y-intercept. And as we move forward, we'll notice that that was written directly into our equation. 0, 4 ends up at 4 on the y-axis. I want you to pause and try this next one. Pause and try the next one. Assuming you've done that, now let's plug in x equals 6. Well, y equals 1/2 times 6 plus 4. Just like we did earlier, I put that 6 over 1, and what I really have is 1/2 times 6 over 1 plus 4. When you multiply fractions, 6 times 1 is 6 on top. 2 times 1 is 2 on bottom, which simplifies into 3 plus 4, giving me a final y-coordinate of 7. So each of those gave me x values to plug in, plugged them in, combined like terms, and I was done. However, these next two give me y values instead. Whoops, plus 4. What that means is I'm going to have to plug in the y on the other side of the equal sign and do some solving along the way. So if I plug in 0 into that y spot, I have 0 equals 1/2 x plus 4. And my goal is to get x alone. So just as we've done before in the solving process, I first undo the plus 4 by subtracting it to the other side. Gives me -4 equals 1/2 x. Next up, how do I get rid of a 1/2? Well, I multiply by 2. I multiply by 2. Remember, 1/2 is the same thing as divide by 2. So to undo it, I multiply. When I multiply, I have 2 times -4 is -8 equals, my 2's cancel out, and I'm left with x. X equals -8. Thought I was wrong for a second. Sorry, y'all. X coordinate of -8. 0 up and down. This is what we call an x-intercept. Now, let's talk for just a minute. Why did I have to solve over here, but I didn't have to solve on any of these? Well, notice here, my y was already by itself. My equation was already set up so that y was by itself. So if y is what I was looking for, I just got to plug in, combine like terms. There was nothing to have to undo. But if x is what I'm looking for, x is not by itself. So I have to go through that undo, that solve process in order to get x by itself. If you would like, if you're ready, try the next one. If you're not as comfortable, that's okay. We're about to do it together. If I can pick a color. So in the last point, they give me a y coordinate of 6. So again, I'm going to plug it in to the y spot. Let me be a little more specific. Plug in y to be 6. So that means I have 6 equals 1/2 x plus 4. To get x by itself, I'm following the same process. Subtract 4 from both sides. Gives me 2 equals 1/2 x. And I get rid of the 1/2 by multiplying 2 to the other side. 2 times 2 is 4. 2 times 1/2 cancels out, and all I'm left with is x. So that gives me an x value of 4 when the y coordinate was 6. And notice once again, these all line up on the same line because this was a linear equation. One more for us to look at. But notice in this formula, in this relationship, x and y, neither one are by themselves. So what we have to do is solve every time. Let's start off with our x's. So I'm going to plug them in to the x spot. If x is 0, that gives me 2 times 0 minus 3y equals -9. Now what you'll notice going forward, when I have x and y together like this, it's going to be these intercepts. It's going to be these zeros that are easiest for us to solve for. Because 2 times 0 simply cancels out, and I have -3y equals -9. When I divide by -3, the y's cancel. -9 divided by -3 is a +3 result. So 0, 3 was my y-intercept. Next up, let's plug in 3. So if x is 3, I plug it in. 2 times 3 minus 3y equals negative 9. 2 times 3, I always multiply first, is 6. That simplifies my life. And then I'm going to subtract that 6 to the other side, giving me negative 3y equals, those are both negative, so add them up, negative 15. Then, to get y by itself, break that negative 3 away by dividing it to the other side. Leaves me y equals, negative and negative turn positive, 15 divided by 3 is 5. 3 on the x-axis, 5 on the y-axis. Let's do one more of those, plugging in negative 6. So I have 2, plug in negative 6. I still have a minus 3y equals negative 9. Well, 2 times negative 6, we're going to multiply those together first to simplify our life. And then to solve for y, the first thing I'm going to do is add the 12 to the other side, giving me negative 3y equals 3. Running myself out of room here. Then when I divide negative 3 to the other side, y gives me a negative 1 result. So 3 ordered pairs on my line. Next, we're going to shift gears because they gave me y values instead. So going back to my original equation, because these are y values, I'm going to plug them into the y spot. 2x. So let's start off with y equals 0. Gives me 2x minus 3 times 0 equals negative 9. Now these are the nicest ones to us, again, because negative 3 times 0 zeroes out, giving me 2x equals negative 9. Divide by 2, divide by 2. X equals negative, well, if we're not sure what that is, 9 divided by 2. 2 goes into 9 4 times, using 8 in the process. 1 left over, so bring in a decimal and bring down your 0. 2 goes into 10 5 times, leaving me negative 4.5 in that x spot. Notice this is an x-intercept because I'm sitting on the x-axis. All right, one more to go. This time they give me y to be 7. So 2x minus 3 times 7 equals negative 9. Go ahead and multiply those two together. So 2x minus 21 equals negative 9. Solving for x, first thing we're going to do, add 21 to the other side, leaving me with 2x equals, well, 21 minus 9. I have to borrow 2, gives me 12. And when I divide by 2, nice pretty number this time, x equals 6. So positive 6 x-axis, positive 7 y-axis, and I have a straight linear line. So this wraps up Notes 22, where we're looking at how x and y values can connect. Please note, you have to have some sort of a formula, some sort of a relationship between x and y in order to find those ordered pairs. In our next videos, we've got 2 more videos to go, 2 more lessons, I mean. In our next 2 lessons, we're going to look at exploring these formulas, this relationship, a little closer. But for now, this wraps up lesson 22.